Hello, this is a quick lesson on 5.3. So in 5.3, we learned all about polynomials. The first thing we did was just talk about what polynomials are. So with this example, we're going to go ahead and I'm just going to state the degree and leading coefficient of each polynomial. So in our first one, the highest degree is 6. So that means that the degree, I'm just going to put degree, is 6. And the number in front of that term is 11. So my leading co would just be 11. Now we're looking at the next one. Our highest degree is 7. So that means the degree for this polynomial is 7. And the leading coefficient is the number in front. Okay, now these have been really nice for us because they're giving us to them in order. Okay, so if they're not in order, okay, in order meaning it's going from greatest to least. If it's not in order, you're just looking for the greatest exponent. So my leading coefficient would be -10 in this case. Now we're looking here, we have x to the 4th, but I want to look at this entire thing. I have x, x, and y. So they told us if it's not a polynomial in one variable, state y. So they just want us to deal with polynomials in one variable. Number 3 is a polynomial. It's just not in one variable because we have an x and a y. Now if we look at 4, x, and y, it's the same thing. So it's the same answer. Okay, because we have x and y, it is a polynomial. It's just not a polynomial in one variable. The next thing we learned, and this was the most important part of 5.3, was our end behaviors. So we have a degree that's even. So it's an even number, 2, 4, 6, 8. Our ends, okay, are always going to be facing the same direction. They're either both going to be facing up or both facing down. So if the leading coefficient is positive, meaning there's no negative sign, they both face up. They're smiling. And if that's the case, the end behavior, so when x is negative, so this is the sign for x is negative, so negative infinity, right, my y is positive, so it's going up. Now when x is positive, so on this side is where x is positive, that should be a sideways infinity. So when we're talking about positive, x is positive infinity, your end is still going up. So that's what this f of x means, it's going up. And if my degree is even, so it's still even, but now we have a leading coefficient that's a negative number. It means that my ends are both facing down. So when I'm talking about x on the negative side, so my negative infinities, okay, my y is also going down towards negative. That's what f of x negative infinity means. When my x is positive, so on this side of my graph, we have positive numbers. So that's positive infinity. My f of x, or y, is still facing down. Okay, so if you look at what we're talking about even behaviors, or even exponent, your y's should both either be negative or your y's should both either be positive, depending on what you have. Now let's say we have a degree, but it's odd, okay? And we have a positive leading coefficient. So if that's the case, then what we look at the second tail, and the second tail should be facing up for positive. Now, because it's odd, our tails are facing opposite directions. So if one is facing up, the other one has to be facing down. So then the question is what direction is y facing when my x's are negative? So when we have negative infinity, my y is pointing down towards negative infinity. Now, when we talk about positive x's, so positive infinity for x, my y, or my f of x, is also going towards positive infinity. Okay, now let's talk about if we have an odd, but the leading coefficient is a negative, so we have a negative sign. So if it's negative, the second tail is going down, which means that the first one has to be going up. So we ask ourselves the same question. When x's are negative, so on the negative side, so negative infinity, my y is going up, so it's going towards positive infinity. When my x's are positive, so positive infinity, we look at the tail, it's going down towards negative infinity. Okay, so this was the major concept of 5.3. Now we're going to look at some problems that ask us about end behaviors. So for each of these graphs, we're going to describe the end behavior. Then we're going to talk about, is it an even function or an odd functions? And we're going to state how many real zeros we have. So for A, we're looking at this graph. It wants us to describe the end behavior. So when my x's are on the negative, so as x's go to negative infinity, we look at the end. The end, so f of x, is also going towards negative infinity. Then, when I look at the positive x's, so this is positive, so when x's are positive infinity, my y, so I look at the end, my f of x, is also going towards positive infinity. So that was A. B asks us to determine if it represents an odd or an even degree. Well, odd or even, we look at the ends. If the ends are facing opposite directions, it's odd. And the last one, state the number of real zeros. It's asking us how many times does it cross the x-axis. We have 1, 2, 3, so we have 3 real zeros. The next one, so our A, they're asking us to state the end behavior. So when x's are negative, so when they go towards negative infinity, we look at the end is also pointing down. So my f of x is also going towards negative infinity. Then if I look at x's on my positive side, positive infinity side, my f of x is still pointing down. So this guy is still pointing down, so it's negative infinity. Then for B, we say, is it even or odd? Well, the ends are both facing down, so we know it's going to be an even polynomial. And the last one, it's not touching the x-axis at all, so we don't have any, so none real zeros. There are none. Our last one for A, again, we're looking for, okay, when x's are negative, so when my x's are negative infinity, my f of x is pointing down. So my f of x is also going towards negative infinity. Now when my x's are positive, so when my x's go to positive infinity, my f of x is also going towards positive infinity. Okay, then for B, they ask us, well, is it even or odd? Well, the ends are facing opposite directions, so it is odd. And the last one, it's only touching the x-axis once, so there's only one real zero. Okay, then our one is if we have equations. They want us to state if it's even or odd and then state the end behaviors. So I'm going to look here, my first one, this is saying x to the third. So and I like drawing little pictures, so I know my ends are going to be opposite. And since the leading coefficient is positive, because there's no negative symbol, so it's positive, it means that my second tail is pointing up, so my first one has to be pointing down. And here's a little sketch. So then my end behaviors would be as x is going towards negative on the negative side, my y is also pointing down towards negative. Then on the positive side of x, so as x is positive infinity, we see that my f of x is also going towards positive infinity. Okay, so that was the first one. The next one we see it's a 2, so it's even. But this one has a negative sign in front of it. So it means that my graph is going to be pointing down. So when we talk about end behaviors, we're going to say when x is negative infinity, my f of x is also pointing towards negative infinity. Then when I say when x is positive, my f of x is also going towards negative infinity. And this makes sense because it's even, so both of my y should both be facing the same direction. Now we look at the 4, x to the 4th, that's even. And we know that it's positive because there's no negative symbol at the end. So that means both of my ends are facing up. It doesn't really matter what the middle looks like. Okay? All we care about is about the ends. So when x is negative, my f of x is positive. And when x is positive, my f of x is also positive because they're both facing up. Okay, and that was the major concept of 5.3. Have a fantastic day.